All right, so in these three problems, it's a continuation of our work with the graspable math activity from last week. So problem number one, they ask you to identify the mistakes. There are more than one mistake. And then go back through and fix the problem. Problem number two, you're just given 2 points and you're asked to find the distance between those 2 points using the distance formula. So again, we've talked about how we can draw a triangle and use Pythagorean theorem. And these problems here, I want you to use the distance formula. So go ahead and if you're working with your partner, then go ahead and work on the problems together. If you're working individually, that's fine. But go ahead and complete problems 1 and 2, turn the video back on, and we're ready to continue. Now, as you work through the problems, if you're finding that you've made a mistake or you didn't identify the mistakes, and you go back and fix the problem, then I would suggest turning the video off, go back and correct your mistakes, and then turn the video back on to continue with your work. So in this problem here, there are 2 mistakes actually in this row here. Instead of subtracting the 2 x values, we're subtracting an x and a y. So it's 15 and 12. Here we do an x and a y as well. So first mistake there is that we're not subtracting the 2 x values and then the 2 y values. The second mistake in this problem is the fact that 16 actually is negative. And these are subtraction problems. We're trying to find the distance and how far these numbers are apart. So it should be 25, it should be minus negative 16, not minus 16. Minus 16 would have meant that the 16 was positive to begin with, not negative. So the distance formula, I'm looking for the difference between the x values and the difference between the y values. I generally just choose one of the order pairs and make those my first numbers, so it's 15 and 12. And then the other order pair, 25 and the negative 16, will be the second number. So I'm always aware of the fact that the order is important, and so if you start switching the numbers around in terms of order, you change the sign. So for example, 3 minus 5 and 5 minus 3, they both give you an answer 2, but one's positive, one's negative. So you gotta make sure you're doing this in the correct order. So d is equal to the square root of 15 minus 25 is negative 10 squared, and then 12 minus negative 16 actually is a positive 28 squared. So negative 10 squared is 100, and 28 squared is 784. You add 100 to that, and you get the square root of 884. Unless this comes out to be a really nice number, as in like 15 or 23 or something like that, we will keep the square root as the answer because that's the most accurate answer. And this comes out to be 29.732. So again, sometimes it depends on what they're asking for. So the square root may not necessarily tell you as much information as you need. So sometimes change it into a square root can provide you some more information. So square root of 884 is about 30. And it's a little bit shy of 30, so 29.732. So this is the actual answer, and this is the approximate answer. All right, so the next problem, number 2. Same steps. So I go ahead and turn the video off if you've not completed the problem. Think about the steps for the first one, any kind of adjustments you need to make with your own thinking to complete the second problem. Or if you haven't started the problem at all, go ahead and complete the problem. Discuss with your partner, turn the video back on when you're ready to continue. So I just select one of the order pairs. So I'm going to do 15 and 89. So 15 goes in the first parenthesis, 89 in the second parenthesis. Then the second order pair, the 46 goes with the 15, and the 4 goes with the 89. So put the x values together and the y values together. So d is equal to the square root of negative 31 squared plus 85 squared. So negative 31 squared is 961. $85 squared is 7,225. So D, the final answer is the square root of 8,186. That's the exact answer. If approximation is needed, because let's say we're trying to figure out a length, the actual length of something, or at least an approximation, we can turn it into a decimal number, and it comes out to be approximately 90.477. For the last problem, again, steps will not change. One of the things in terms of doing problems, kind of develop good habits. So you can choose whatever number, you can choose whatever order pair you want, but if you notice my setup has always been the same. D is equal to the square root of the parentheses under subtraction squared plus the other parentheses under subtraction squared. And I can always choose an order pair, my first numbers, and the other order pair is my second number. So if you go ahead and complete this problem, check your answer with your partner, finish, turn the video back on. Negative 32 and 78, 46, and negative 12. So D is equal to the square root of, so this is negative 32, minus 46, which will give me a negative 78 squared, plus 78 minus negative 12, that would be a positive 90 squared. So 90 squared is 8,100, since 9 squared is 81. And the negative 78 squared is 6,084. The distance is the square root of 14,184 when we add two numbers. Check to see if it comes out to be a nice number, which it does not. We do have an approximation. It's about 119.097. Again, for the actual answer, again, sometimes turning it into a decimal number can be helpful, especially if you don't know your square roots real well. You're trying to figure out how long the segment is. Turning the square root into a decimal number can at least let you know that the segment's about 119 units long. We're going to continue with distance formula this week and into next week. It will definitely be part of your next test. So go ahead and move on to the next activity.